All right. Hi, everybody. My name is Aaron Krickenberger. Today is Tuesday, April 10th, 2018, and welcome to the weekly Kubernetes SIG testing meeting. First off, we're going to start off with Rowan's API Snoop demo and proof of concept. And then I had a couple miscellaneous things I wanted to ask the group about in terms of things to talk about in KubeCon and just kind of some plans in the 111 timeframe. So with that, I will hand off to Rowan.
Hi, just give me a sec. I'll just share my screen. Okay, there we go. So I might just start with just a little bit of a brief presentation about API Snoop and what it hopes to solve and where we're going with it. Just give me a sec, share screen. Okay.
We can see. Yep.
Okay. So what problems does API Snoop hope to solve? Well, a couple of things. So first thing is that I've heard that Kubernetes test coverage is currently calculated using ETE logs. And I guess like what we'd try and do is calculate that API coverage in a more generic and reusable way. We're also, the conformance working group is working on raising ETE tests. Currently that test coverage rate is 11%. And I guess, you know, we can try and work out a way to prioritize these tests based upon, you know, how often certain API endpoints are being used. Another thing that API Snoop hopes to solve is this idea of add-on conformance for a given release. So like, does an add-on use stable alpha, beta APIs? And do all API requests and responses conform to the Kubernetes Open API spec? So the idea is to create like a generic usage map against an Open API spec. So, and then present the results in a form that's easily accessible to, you know, to testing, to inspect all API calls made from clients, ETEs and add-ons, and then compare those request responses to the API spec, which we can grab from the Kubernetes API endpoint or repo, and then track API usage calls by pod, by source IP, etc. And so at a high level, inspect the API requests instead of ETL logs or Kubernetes auditing. And then we can reuse this implementation outside of Kubernetes. We can redirect API, so we redirect API requests to the proxy. At the moment, it's using IP tables, and it only affects certain pods with annotations. And then we're planning to reuse MITM proxy, which is an existing project, so we don't have to start from scratch. And at the end, we hope to create a reusable Open API inspection logic as a plugin. And so, yeah, that's just a brief sort of overview. Is there any sort of questions before I start demoing?
I wouldn't use frequency as the target of what to determine as the highest priority things to have tests on. Obviously, that stuff has typically been tested fairly well. Usually the coverage, you'd want to determine from either this SIG or SIG architecture, what is the highest priority things to evaluate.
Okay, so it's less about frequency and more about like priorities that are given at the by a group of people sort of thing.
Yeah, basically anything within the V1 API that's been determined as these are the most, prevalent APIs in usage.
Uh-huh.
I would
Okay.
expect SIG architecture to have a stronger opinion on that. And yeah, Eric was asking in chat, is this related to what Hippie Hacker was telling us about back in?
Yeah. So I mean, so Hippie Hacker, he couldn't be here this morning because of he has a doctor's appointment in about 20 minutes, so he's actually in transit already to the doctor. And it's completely related. It's the same project basically. So this is like a proof of concept to just show that it's possible. And now we're like what's next for API Snoop. So we're refactoring that complexity and then building a reliable Helm chart that we can deploy. And then that's when we start to write the MITM module and collaborate with test info. But SIG architecture is interesting. Like maybe we could, we should go and talk to those guys as well and see what they have to say.
Yeah, I mean, I bring them up because technically SIG architecture owns the definition of what is and is not a conformance test. So they're going to have opinions on like the subject matter. We're more interested in the execution.
I see. Okay, that's a very good suggestion. I'll make a note of that and talk to Chris about it. Okay, well, I'll give you a brief demo.
One more comment.
One more comment.
Sorry.
I added it as an agenda item too. Hi, I'm Mitra.
Hi.
I wanted to introduce some people on the call. We have some vendors from Globant who are joining us, and we'll be actually writing conformance tests to improve our coverage. So you might see them asking questions on our SIG testing Slack from time to time. If they do, please help them out with respect to conformance testing and any questions they might have. I think Jose, I remember seeing Jose on the call. If any of you are here, can you say hello?
Yes, we are, definitely. Thanks a lot for this introduction, Mitra. Hello, everyone. It's really nice meeting you all. And we're really looking forward to working with all of you. I think the technical questions and all specific questions, Kuri is the one doing those. So I will let her talk if there's anything punctual we need to share on this session.
Sure. Thank you for the introduction, Mitra. And it's a pleasure to have the chance of working with you. And we'll be actually doing some questions, making questions, and looking forward for this. Thank you.
Cool. Okay, Rowan, you got a demo for us? Cool.
Yeah, let's walk through the actual thing. So at the moment, I've got just a cluster running on GKE. And there's a couple of things to note about the cluster when it runs. Here we go. So at the moment, we require two things: Kubernetes alpha features enabled, and also legacy authorization enabled as well, which is basically just RBAC is disabled. Those are the two things that we require when a cluster is spun up.
Wait, can I ask a question real quick there? Why are you disabling RBAC? Because that should be part of your conformance suite.
So the reason that, so this is just a proof of concept. It was just mainly our objective was to show that we could actually intercept the traffic between a pod and the API server. And so it was mainly just trying to, as speedily as possible, get it so that it could intercept traffic. And one of the things that we ran into, which we didn't consider to be impertinent at the time, because we were just working on a single objective, was that when RBAC was enabled, like it was, there were certain permissions errors, and rather than trying to work out like how to fix those, we just disabled RBAC in the interim. So one of the things we'll be doing in future is looking at how to make things work with RBAC as well. It's probably, it's just, I guess, something that needs to be looked at rather than something that is like a hard and fast requirement of this approach. So yeah. Okay, so that's the cluster running. And then,
what alpha features are you using?
Initializers, sorry. So this work is based upon some work. It's called, I think it's called T-proxy, and it basically it uses initializers to intercept deployments that are deployed, and basically injects sidecar containers, environment variables, and I think like initializer containers. At the moment, it's also setting an annotation on some of the templates as well, which is what's then being picked up by another part of the architecture called like there's a container in there called PodWatch, which is basically looking for those annotations. So once again, it's like, I mean, this is kind of the complexity of the proof of concept that we're looking to simplify. But it's
Can
just,
I ask
sorry.
a quick design choice question?
Sure.
Is there any reason why you didn't just put a proxy or a load balancer in the front end, just route all traffic through that load balancer, and do like certificate termination at LB?
Okay, so why did we not use the load balancer? Okay, so once again, this is, I mean, the whole idea is like to have a, it was to once again to show that it was possible to do this, and so we looked for existing solutions that allowed you to peer into the traffic that was coming from the pods, and there was one particular project called Kubernetes T-proxy that was built more to allow to sort of like intercept, you know, HTTP requests to the outside world, so that it would sort of lock the pods down so that they would only talk to certain HTTPS things. So what we did is we modified that instead to intercept traffic between the pod and the API server. So it was more of a using of an existing solution rather than a design decision as such. Yeah. Does that answer your question? Do you have any more questions?
It leads to more questions, but I'll just hold them for now.
Okay. Thank you. Okay, so I'm just going to check out the code first of all. And I'll just pull it up here as well. CNCF. No. All right, so it's still currently on GitHub as we speak. So first thing is just to make sure that Helm's installed, which it is. Okay, so the first step is to basically look at, so the first step is to create a certificate signing request and send it through to the Kubernetes API server. So what we do is basically look at the internal IP of the cluster as well as external IP, and we have a CSR settings template, which is here, So basically what we do is we just ask the API server to sign a certificate which pretends to be the API server, which is kind of interesting. So it just replaces these two IPs here, and then that gets submitted off. And here's the CSR that's been submitted to Kubernetes. So we just put the CSR here, and then approve the CSR and get the result, and that goes through to the MITM proxy. And then the next thing is to we set up T-proxy. So we basically just install a Helm chart with initializers enabled and that certificate that we just created. And then what happens is it sets up a MITM proxy on each of the nodes. And then, sorry. And then once you've done that, I mean, those first two steps, then the system is basically up and running, and sorry, incoming call there. So then we can deploy our example app, and then all we have to do after that is basically annotate the pod and that we deploy, like the example pod, and then the traffic will be intercepted by this API snoop. So I'll just do that quickly. So here we are, we're creating the Kubernetes API certificate. Now we're setting up T-proxy using Helm. Here we can see that we've got a T-proxy running on each node. This is a free node cluster. Next we'll deploy a example app that basically just this app basically has kubectl inside, and it just calls kubectl get pods like every 5 seconds. And then the next step is to work out which we can do it this way. So we can work out which T-proxy is related to the example app. Now, so currently, for the sake of the proof of concept, we have to manually do this because we're just going to port forward onto that particular T-proxy pod and get access to the web interface of MITM proxy. In the future, like it would be sort of exposed as a surface. API snoop would be exposed as a service to basically allow you to access it without having to do pod forwarding and all this mess. But as I said, it's just a proof of concept. So I have a little bit of magic here that basically works out from that output where everything is. So the T-proxy pod where the example app is here. So it's on that one. And then what we can do is we can port forward that pod to a local host. And then we get so this is the MITM web interface running on that particular pod, being port forwarded to localhost. So if we look at the kubectl kubectl logs for the example app, we can see that it's calling as we speak, but nothing's coming through, and the reason is because we haven't set the annotation on the pod. So if we now go annotate, then the pod is now annotated, and we should see the results. Here we go. So this is the traffic being intercepted on that particular pod, and we can see the authorization bearer, etc. It doesn't keep the response from request currently because MITM Web keeps this all in memory, but the request and response can be intercepted as well. So this proves that it can be done using this method, and basically, so we'll use this as a base for like what we do next. And yeah, any questions?
So I guess my question is this approach of hooking up, it kind of seems like you're hooking up a sidecar to a pod. Like, this doesn't seem super substantially different from capturing logs on the client side as opposed to the server side. Unless I'm misunderstanding.
So I think, and so you'll have to excuse me. So Happy Hacker is a little bit better at sticking this into words than I am, but so I guess this is where this like this usage map comes in. I think the idea is conformance on the, so it's all about conformance based upon HTTP requests intercepted on the wire. The idea of if HTTP requests are malformed, then like your client side or your server side would be unable to, like it's like they could get filtered out earlier in the process. You know, like you've got logic between, you know, when things are intercepted on the server side and whatever mechanism you have behind that logs things in the same, I guess, as on the client side. I guess also the other point is that if you do it this way, then it requires, it's like you can use this for any sort of thing where you're trying to intercept the API traffic, and you don't need that logic built into your application. You can just, you know, you just need to basically insert yourself in between what the server and the client, and then you can intercept the traffic and then use that to check for conformance against your open API spec. And then I guess one of the ideas, as I might have said before, is the idea of reuse. So like, yes, this can be used for Kubernetes, but it could also be used for other open source projects. Yeah.
Could this, you know, be used for a general like gRPC intercept?
So I've heard of gRPC. I honestly have not looked into gRPC. Is it something you could explain very quickly? Like, how is it different from a web request? Like a REST API call?
I don't know, it's sort of just Stubby is sort of, I think Stubby uses HTTP, but there's some other, you know, mechanics around turning a HTTP endpoint into a service. So it might be, you know, is used fairly extensively in, you know, around Google. So I could sort of see if there's, if I publish a proto that says what my, you know, similar to the Open API, I don't know the technical details about if it's similar or not, but it seems like that could be used for, there's a lot of potential, you know, to make this intercept all sorts of different things.
Okay. Yeah, and that's something that we could look into. I mean, I couldn't tell you off the top of my head, but it sounds interesting, and I'll make a note of it, and we'll look into it after this meeting as we go along.
Okay, cool. Thanks for your time, Rowan. Yeah, I mean, like when I talked to Hippie, I got the sense that this would be super useful for pretty much any open API based service, not just Kubernetes. And so I think that's a really laudable goal. Yeah, so I don't know that we really got to see a proof of concept last time. We've seen it this time. That's great. I think figuring out how to like start to automate this moving forward, we're definitely interested in that. So we're kind of coming up on time, so I don't know that I'm really going to be able to go through the full laundry list of things that I had. I'll just mention real briefly, I'm heads down on trying to work on slides for KubeCon, and one part of my talk that I would like to give is focused around success stories of what SIG testing has managed to accomplish over the past 2 years or so. And I want to tell those stories, if I can, in the form of like, here's a graph that shows what it was like before, here's the thing we did, and here's a graph of what it was like after. So I'm happy to like discuss potential ideas in Slack to figure out what would help there. The one like really good one I found thus far is actions we have taken that have increased the percentage of merge commits by the bot versus by humans. The more time, the lower that percentage, the more often humans were subverting the submit queue and pressing the merge button on their own. And it's like way up in the 90% now, which is super cool. That kind of happened shortly after we turned off post submits blocking the queue. Shocker. I think the other question I had just with KubeCon in mind is I always love demoing our BigQuery based metrics, but I feel kind of bad when we get to this dashboard, and you probably can't see it, the numbers are really tiny, but like we've had jobs that are failing for over 200 days, over 100 days. I feel like it would be really nice to get rid of these and make them go away prior to KubeCon. I don't know who we need to ask about that. The majority of these are GKE or GCE related jobs, not entirely. So maybe there are folks we could poke inside of Google. And I think that's about all the critical stuff I wanted to cover. Anything from anybody else?
So for the approval breakouts and then the config breakout, which is happening immediately after that, do we want to, I feel like since the meeting is scheduled on the Google Hangout, we should probably, people interested in that should migrate over to the Hangout, but I wanted to discuss whether we wanted to do that.
I'm fine hopping over to the Hangout, calling this one done.
Can we record on there, Eric?
Yes.
Okay. That's hop, so if someone wasn't in this meeting, they don't show up and it's an empty room.
Right. Yeah.
All right. Cool. Thanks, everybody. See a couple of you in the breakout in a little bit here.
Bye-bye.